Hi everyone. So in this video we want to talk about two additional attributes that usually come with the active attribute that we already talked about, and that is animated and deforming. And this already might ring a bell because we talked about animated and deforming in the context of moving collisions. So remember this example here with our truck and our boxes, and the best way of dealing with moving geometry is to use the animated collision type, which needs us to pack geometry before we animate it so that the animation is on a packed geometry. And if we can't do this because the geometry might come from the animation department, then we can use the RBD deforming to animated node to turn basically a deforming geometry into an animated geometry. Now this dealt with passive geometry, but now we want to use the similar concept for dealing with active geometry. And for this we have our helicopter here. And by the way, this helicopter you can download from a link that I provided on the site from TurboSquid. Unfortunately, I can't directly give you the geometry because I don't have the rights to do that. But as you can see, you can download it yourself and then rebuild what I have here. Now what this is about is that this helicopter here is animated. So I animated the rotor and all this. So the helicopter goes brrrr. And we want to now take this animation but still destroy our helicopter because of course we want. But now we run into a problem. How can we keep this animation and still destroy our helicopter at the same time? Now let's set this up. So let's put this into RBD bullet solver. And as usual, I assemble this. So create packed primitives and then put it into the bullet solver. And let's activate the ground plane. There you go. And what happens when I press start is it falls down and crashes, which is not what we wanted, because we actually wanted to have our beautiful animation here where the helicopter flies. But by default, what will happen here is that we just put this in as an active object. It will be simulated based on the first frame, and any animation on top of that will be lost. Now to change that, we actually have the possibility of telling the RBD bullet solver that this is an animated version of our simulation. And there are two ways of doing this. We can do this with an RBD configure, because here, this is the easiest way of doing it. This is already pre-built as one of the main attributes that you can set here. And this is under bullet data. Here are the three that we want to talk about: active, animated, and deforming. You can do the same in form of the point wrangle, because all of this is it's creating the three attributes as it says. So active, that we've already seen. So let's set this to 1. We can use animated. Let's set this to 0 for now. And we can use deforming. It's not deformed or something. It's deforming for some reason. Don't ask me why. So the naming here is very important. And by default, in both cases, we have set the active to 1 and all the other to 0, which is basically just the same as before. You know, our helicopter will fall down. Now what we want is this to animate. And we already talked about the difference between animated and deforming. Deforming means we have a non-packed geometry and the movement is basically on each point. So this is actually the case here, because while we have an animated version here of the helicopter, there you go. If we pack it afterwards, as we've seen in the last chapter about animated and deforming, it doesn't matter that it's packed. Just because it's packed and it's moving doesn't mean it is an animated object, because basically the animation is in the deformed version that is then just packed again. So if we would try to now set this to animated and run this, we can see it's not working. It just stays in place. What we would have to do in our case here is set this to deforming, and then we would see that this actually is moving. But as we've seen before, the same problem as with the static object is that it's very slow, because basically it's recreating the helicopter every single frame or even subframe. And also later on, we would see that there are problems with the collision. So how do we solve this? As we've seen, we can use the RBD deforming to animated. And this way, we actually don't need the assemble for packing this. Be careful, we don't want to pack it twice. We just wanted to create a name attribute so that the RBD deforming to animated will create the packed versions of it for us. And now if we use the animated, we can see that we have our animation back, and also in a very fast way. So that's great. As an alternative, again, we could have done this with a point wrangle. So let's say set the animated to 1, same result, because it's all just about the attributes. And this is basically like we talked about in the last chapter, how the collision objects behave. It's the same logic. Now the difference here now for us is we don't just want this helicopter to move, because then honestly, why would we need a simulation? We want this helicopter to react to something, or we want to destroy the helicopter somehow. The easiest example for this right now is just to put something in the way of the helicopter, for example, this massive box. The problem is, as you might imagine, we have now a new problem that we didn't have with a static object. We actually want this to interact with this box. And currently, if you run this while it's fast, we cannot make the helicopter react to the world, because all we did is we said, listen, this is an animated object, and that's it. Now what we could try, and actually let's use the RBD configure this time, because we will actually use it later, because it has some options that we need. Why not try to set the active to 1 and the animated to 1 at the same time and see what happens? But what happens now is that the helicopter is starting to move, but then instantly turns into a simulation. Now, to be fair, this is actually a very new behavior of combining active and animated. In the last couple of versions, this would result in basically a double transformation. So it would have been animated and simulated at the same time, which just would create a mess. It looked very funny, so it was nicer to show this in the older versions. But nonetheless, you can see this is actually not what we want. Because I think what in the newer version of the RBD bullet solver is happening is, as soon as the active attribute is 1, all the others are ignored at the first frame. So while it doesn't look like a complete mess anymore, it's still not what we want. We wanted the helicopter to move towards the box and then brake. Now, one thing you can do, just as a thought, is you can always switch between those two states. So for example, what you could do is, let's say we use one version where the animated attribute is active, and a second version by just copying that node where the active version is active. And then at the right point, we just switch between the two. So what we can do, for example, is we can look when the helicopter is hitting the geometry, maybe frame 1021. So we could say if the current frame is bigger than 1020, let's say, then you switch to the active version. When you look at this, it seems right, and then it just, it doesn't really look believable, because you can tell that at some point it touches the nose and all of a sudden everything breaks apart. Side Effects actually came up with a better way of solving this problem, of switching between the animated state and the active state. By the way, this all would also work for deforming, but as we've seen, we don't want to use deforming because this is usually inefficient, so we will keep working with active and animated. And this is actually something that is already built in the RBD configure. When we go down a little bit, under collisions, there's actually the option of switching between those two states in the moment a collision happens. And this is here a little bit hidden under min activation, and let's mouse over it, min activation impulse. If you read through this, you can see that it actually is taking care of switching from inactive to active based on a certain impulse in the collision. Now, this impulse can actually be read out. In the RBD bullet solver under output, you can actually turn on impact data, and then you would be able to read out what the impact actually is for each object that you are simulating. But most of the time what you can do is just, increase it to a number that works and just play around with this. And as you can see, by the way, which is a nice coincidence, down here you can see all this is just an additional attribute that is created on our packed geometry called min activation. So if you wanted, you could actually create this yourself with a pop wrangle, of course. Now, if you would leave this at 0, technically the helicopter should instantly implode because, there is not enough impact. But it doesn't. And also what's even weirder is once there is an impact, you can see, already how the idea behind this is. But the weird thing is it goes together and apart and together and apart. And what is going on here? Now, the problem is that we still have a function going on here that fights this a little bit. And that is in the RBD bullet solver. Remember, under properties, this is the list of all the attributes that our RBD bullet solver is constantly reading in. It says here override attributes during the simulation. Now what you could do is you can just turn this off and then run this, and you can see this actually now works. It instantly breaks apart. That we will talk in a second about. But as you can see, you need to either turn this off, or what's actually better is there's already a function to making sure this doesn't happen. And it says here, override activation with min activation impulse. If you turn this on, it understands, well, don't do this if you have a min activation impulse. So this min activation attribute here. As soon as it finds that, it doesn't do this anymore. So it's better to leave this on, just turn this function on, and then you basically have the same behavior. Now we still have a problem though, and that is that our helicopter instantly breaks apart. Now, theoretically, like I said, this could be because the min activation impulse is currently 0. So let's slightly increase that, or maybe even a bit more, and see what happens. And unfortunately, it still happens. Maybe a little bit later now, but it still happens. And the reason is actually not the min activation impulse, but the reason is that our helicopter actually collides with itself. So if we look closely here, you can see that a lot of geometry is just stuck inside of each other, which is totally fine. You basically cannot prevent that in modeling. It's impossible. So there must be a better solution of solving this so that the geometry itself does not create a collision impulse. And this is already built in because here next to it in the RBD configure, there is an activation ignore parameter. And in here, you can put everything that you don't want to collide with itself. Now the question is, what do we put in here? Unfortunately, it doesn't really explain this to you properly. When you look into the help, it just says the pattern uses the same syntax as the collision ignore attribute. Okay, where's the collision ignore attribute? There it is. That just says set the collision ignore attribute to the specified value. So this is not really helpful. As usual, thank you side effects for nothing. So what it actually means is that the RBD configure itself can create its own group, which is a collision group. This again is just an attribute called collision group, which is specific for this whole workflow, which is actually a topic by itself, because this way you can control what objects are colliding with which we haven't covered because it's so rarely used, but in this case we need it for this technique. And here we can just call the whole thing helicopter, for example. So that just means everything that goes into this RBD configure will have a collision group attribute called helicopter, and this helicopter group we actually put into the activation ignore. So it's relatively simple, but not easy to figure out because the explanation of it is really lacking. And again, let's look at the attributes. We have now a collision group attribute and also an activation ignore group, both strings obviously. So if you wanted to do this yourself, those are the attributes you would have to set. And now if you press start, we can see that our helicopter is not exploding anymore by itself, but only once the collision is actually happening with our big blue box here. And then we actually get the nicest version of our switch here, because it only activates the collision of the objects that are actually involved in the collision, and the stuff that comes from the back then one by one starts to activate, which of course looks very nice. Now what's completely missing here is any kind of constraints. So any glue that holds the stuff together. This is something we'll talk about in the next chapter, but for now you can already see that you can create some cool, interesting stuff with that. Now for a case like this is great. This works pretty well, but just to be clear, there are certain cases where this approach is not working and we actually have to rely on a simple switch. So for example, what I have in this version here is I don't have a box or something, I have a missile that is actually following my helicopter. Now, how I set this up doesn't matter. You could hand animate this. I will provide the file for you. So if you're interested, you can analyze this a little bit. It needs some Vex knowledge, so this should not be topic in this video, but have a look if it interests you, but you can always hand animate this yourself. It doesn't matter. And the problem is when I use the setup that I just showed, then this happens. Only a few parts of the helicopter will break apart and the rest will keep moving forward. But what we actually want is that the whole thing basically explodes. And in a case like that, I would not actually use this activation functionality. So let's turn this off again. In this case, I would actually manually do a switch that I showed in the beginning. So I'm not saying that the switch per se is always a bad idea. In this case, we have the impact of our missile at frame, what is it? Let's say 1049. So I set the $F bigger than 1048. There you go. And now if I'm running my simulation again, the missile is getting closer, and once it hits, the whole helicopter is falling apart, which of course, if you would combine this, with an explosion and all that, looks much better than if just certain parts would activate. So there's nothing wrong with a manual activation of the whole system. But in our collision example here, of course, an activation is the better approach. So maybe you could come up with another way of switching between the animated and the active version of your geometry. Feel free to come up with your own ideas, but those two I would say are the most common. So yeah, this is how you switch between an animated version of the geometry and make sure then it's still animated when it needs some kind of reaction in your simulation. Keep in mind that still there is this logic of what is animated and deforming. So ideally you have actually a packed version of your geometry that is then animated. And if you don't have that, which is actually not the case most of the time, because usually the animation comes from the animation department. Remember, just like with static objects or passive objects, you have the RBD deforming to animated to turn your deformed animation into an animated animation. So play around with this a little bit because it can be a little bit confusing if you haven't done this a couple of times. But nonetheless, I hope this is helpful. So thanks very much and see you later. Cheers.